Draw a shear and moment diagram for the following beam. To solve a problem like this, you need to start with drawing FBD for the entire beam and using it to find the support reaction, which already I have it in here. If I take moment above B and I assume that this is my positive direction because I'm following the direction that A is going to act, I can find AY from there. So AY times the distance is 4 meter minus 3 times the distance that is 1 meter is 0. Therefore, AY is 3 over 4 or 0.75 kilonewton for A. Now, if I write sigma BY is 0, clearly BY plus AY needs to be equal to 3. That means that BY is equal to 2.25 kilonewton. So I have both AY and BY. Now, this is my AY and this is my BY. This is 0.75. This is 2.25. Now, to draw a graph, you need to start from the left side, which is this point, and move alongside the curve. Now, and you're going to use the sections method. If I draw a small free body diagram for the segment from A to B, I have 0.75 acting in this direction, and the positive V on the left side is downwards. So I'm going to draw separate free body diagrams for V and M because I don't want to mix them. So sigma Fy is 0. Therefore, 0.75 minus V is 0. From here, I can tell that V is equal to 0.75 kilonewton. So it doesn't matter if I'm slightly after A or if I'm 2 meters far from A. This is the free body diagram and nothing is changing. So I have 0.75 and it's going to be flat. Nothing is changing all the way to this point. So you can see that for the left side, shear moment is equal to the value of support reaction, and its sign also is the same. If it's positive, this is going to be positive. But from B to C, I'm going to assume that there is an X changing from 0 at point B to 2 meter at point C. So from B to C, I'm going to draw again free body diagram. So I have 0.75 in here and I have V in here. The distance from here to here is X. Therefore, I can say that I have a force that is acting in here and its value is 1.5 times X. Okay, so X is going to be 0, 1, 2 because it's between 0 to 2 meters. Now from here, I can say, again, by writing sigma Fy is 0, I can say that 0.75 minus 1.5x minus V is 0. Therefore, V is 0.75 minus 1.5x. Now, this is the equation for my V for segment that is between B to C. Now, if I put values for X from 0 to 2, I can know how much V is in this segment. Let's start with putting X equal to 0. From there, you can see V is going to become equal to just 0.75. So 0 is point B. At point B, you can see that my value is 0.75. That's correct, so it's checked. If I put X equal to 1, then V is going to become 0.75 minus 1.5, and that's going to be negative 0.75. Therefore, at 0.1 meter far from 1 meter far from the from B, I have something equal to negative 0.75. And if I put x equal to 2, you can see that V is going to become 0.75 minus 1.5 times 2, and that's going to be equal to negative 2.25. Don't forget, I'm putting x as, first I put x0 in this equation, then I put x equal to 1 in this equation, and now I'm putting x as 2 because the last point is 2 meters from B. 2 in this equation. And you see that I'm getting a value for V that is equal to negative 25. So I'm going to extend it to this point, which is negative 2.25. How much is support reaction at this point? Is 2.25. Oh, that's great. That means that these two guys are meeting with each other. On the other hand, for the left side, for the right side, for point A, you can see that value and sign for shear and support reactions are the same. For the right side, value is the same, sign is the opposite. And the reason for that, if I draw free body diagram for just point C, I have 2.25 acting upwards, and you know that for the right side my positive V also is upwards, so slightly to the left of point C. If I write sigma if y is 0, then 2.25 minus V plus Z is 0, therefore V is negative 2.25. So these are going to be your benchmark. From the beginning, you can say that at point A and at point C, I'm looking for these values. But the direction of it, the sign of it, for the left side is the same as what you have for the support reaction. For the right side, for point C, they are different. So the sign is going, value is the same, but the sign is changing. I need to find this distance also, which is x. I'm going to use again another x to show it. So this x is where my V is 0, because you can see that V at this point is 0. To find it in this equation, I assume that V is equal to 0, and from there I can find that x. So V is 0. That means that 0.75 minus 1.5x is equal to 0. That means that x is equal to 0.75 divided to 1.5, and that's going to be 0.5 meters. So I calculated where these two graphs meet with each other. The reason for that is because at this point I'm going to have the maximum, or depending on the graph type, the minimum M value. So somewhere half meter far from point B, I'm going to have my M that is maximum in this particular graph. Now, let's start for M. So this is pretty much what we have for V. I'm just going to explain it in other language. When I'm at point A, there is a 0.75 feet force acting upwards. It's putting a jack and pushing me all the way up to 0.75 meter level. Then I'm walking alongside the beam from A to B. There is no force acting, therefore I'm just walking at this level, which is 0.75 kilonewton. As soon as I get to point B, I can see the effect of this distributed force, and you can see that this distributed force is pretty much going to put more and more weight on me. So when I'm at this point, clearly the magnitude of the weight that I'm holding from this total distributed force is less, then it increases, so it's pushing me in this direction downwards. And at this point I know that I have to get to this 2.25 kilo newton, but in the negative, so it goes from 0.75 all the way to negative 2.25. Let's solve for m. So for m also, we are going to again draw free body diagrams. So from point A to point B, as you can see, we have just 0.75. To start with, you know that at point A, because it's a pin type of support, therefore m is 0. The same is for point B, because it's a roller, it's going to be 0. So I will go from 0 to somewhere, and from somewhere all the way to 0. These are going to be my benchmarks. So this is my m1, and the distance is 2 meter. I'm taking moment about this point. Sigma m about that point is 0. From there, m1, this is my positive direction. So m1 minus 0.75 times the distance is 2 is 0. Therefore, m1 is going to be 1.5 kilo newton meter. So at a point that is 2 meter far from A, I have m that is 1.5, and from 0 to that point, my moment is changing inclined. Okay, it's changing this direction. Also, I will go up to some point in here, and then I will go down. I said that in this point we will have the highest moment. So I'm drawing free body diagram again, similar to what I had over there. I have 0.75. I have 2 meter in here, 2 meter, and then from here to here I have x meter. Again, I have a distributed force which is going to be 1.5 x 1.5 x in here, and that's going to be 1.5 x half far from, so x half far from this point, because it's in the middle. Okay, because the distance is, instead of 2, the distance is x, and therefore because it's a rectangular, it's going to be in the middle, which is x half. This is my m2. Again, sigma m is 0. This is my positive direction. From there, m2 plus 1.5 x times the distance, like I said, is x half. So 1.5 x is the value of the force. X half is the distance from point that we are taking moment about it. Minus 0.75 times the distance is 2 plus x. By looking at the drawing, you can see that it's 2 plus x. It's equal to 0. Therefore, m2, I can directly move the other parts to the other side of the equal. So it's going to be negative 0.75 x squared. So 1.5 divided to 2 is equal to 0.75, and x times x is equal to x squared, plus 0.75x, so I'm writing this part, plus 1.5. So this is my m. The same way that we did above, we are going to put some values for x from 0 all the way to 2, because it's acting from 0 to 2, and find m. So if x is 0, you look at this equation, I'm putting in this equation, m is going to be clearly 1.5. This matches with what we had in here. It's 1.5. Then if I put x equal to 0.5, because we said that at 0.5 meter we will have the maximum m. So M is going to be, if you solve it, it's going to be 1.64, 1.65. So therefore, this will go from here to here in a curved way, okay? Because our equation has x squared, it's curved. So that's going to be 1.64. If I put x equal to uh, 2 meter, you can see that m, if you solve it, m will get equal to 0. If you put x equal to 2 in this equation, we go to 0. Therefore, our curve is this type of curve. And it goes from 1.64 to 0. Don't forget, when we have a distributed force which is in between two supports, because it's going to bend in this direction, therefore our moment is going to be exactly the opposite, and it's going to be a bow upwards in this direction. And that's pretty much we have in this for this segment. Okay, that's what we have for this segment.